step 1003, say go, no go for launch. OTC? OTC is go. TVC? TVC is go. PTC? PTC is go. LPS? LPS is go. ITD? ITD? PTC NTD? Go ahead. Okay, get ITD up, please.
ITD is ready to resume the count. We'll give you a final curve for launch when our whole fire system is enabled.
Copy. Flight? Flight NTD? Mala?
Let's go for launch.
STM? STM is go. Safety console? Safety is go. SD? SD is go. CDR?
STS-34 is go.
Copy. LRD? LRD is go. SRO?
SRO go, pending a final clear to launch from range safety.
Houston flight NTD? Houston flight NTD 212.
Call flight.
That's firm. We're looking for go for launch.
We have a go for coming out of the T-9, but we're no go for launch at this time.
Is that because of weather?
Because of weather.
Understand. Launch director NTD, step 1004. Launch team's ready with the exception of flight for weather. Copy, and I'll be back to you with my poll here in just a few minutes. Roger.
This is Shuttle Launch Control at T-minus 9 minutes and holding. Got about 15 more minutes left in our built-in hold here. We'll now be going to Mission Control in Houston, finding out what's going on there in preparation for today's launch.
This is Mission Control Houston. In the flight control room at the Johnson Space Center, flight controllers have all given go for coming out of the T-9 hold. However, we are no-go for launch based on weather at the Kennedy Launch Center, and also we are looking at the weather situations at our transatlantic abort sites. Those are Zaragoza, Spain, Morón Air Base, Spain, and Ben Gurir, Morocco. The Flight Dynamics Officer, along with the JSC Weather Officer, the Kennedy Weather Officer, are coordinating the most recent weather data from sounding balloons and local observations at the Cape and the TAL sites. The plan is to continue to the come out of the T-9 hold and count down to T-5, where we can hold again as we did yesterday, waiting for the most recent weather data. This is Mission Control.
Payload bay purge, flow rate for launch.
In work now.
Minutes from picking up the count at T-9. The count will pick up at T-9 in 12 minutes. Countdown clock will pick up in 11 minutes. GLS NTD. GLS, go ahead. Okay, we're going to come out, right now the plan is to come out of the hold at the end of the 40-minute hold. Okay, and your TMT for that is 1641. Copy.
OTC HYD 212.
Ready, 20.
Okay, this time I'd like to report a hydraulics water spray boiler trend. Water spray boiler 2, vent temp 1 is trending down. Currently at 130.06 degrees. When we drop below 130, we'll lose the water spray boiler 2 OK indication, and that'll cause us on panel R2 to lose the water spray, or correction, the APU ready to start talkback. That's the same condition we had yesterday. And recommendation is that we continue the count and have GLS mask the Victor 58 X0282 Echo 1 measurement and brief the PLT that he'll not have the APU ready to start indication for boiler 2. Correction, APU 2.
Okay, copy entity. SPU concur. SP concurs. And GLS, you ready? GLS, you ready to mask that? And this is SP, we've completed that. Okay. Okay, and HYD, you want to go ahead and brief the crew?
That's from PLT, CHYD.
PLT copied the conversation, and I've got no questions.
And QC, what's your next step here number?
Next step here number is 34RV-0247.
Okay, we'll clean that up after launch. There's no constraint to launch.
I copy.
And CMQC?
TMQC?
Yeah, we may have taken a nap here yesterday on that. If we did, we'll just go with that one, or we'll pick up a new one. But again, we'll clean it up after launch.
I
And
copy.
NTDSD, what was the IPR for? Water spray boiler. No, sir, we don't need one for that. That's an expected condition. Understand? Based on the environment. Understand. Cancel that CMQC.
Copy.
NTD SRO on 212.
Stand by, SRO. Countdown clock will pick up in 7 minutes. Go ahead, SRO.
Roger, you have a final clear to launch from the range.
Understand. Thank you. Now this NTD to the test team, could you hold the conversation down in the firing room? OTC CPVT. Go ahead. Flow rate reduction is complete. That's D1602.
This is shuttle launch control at T-minus 9 minutes and holding. Now about 5.5 minutes away from picking up with the launch count today for mission STS-34.
I copy.
Flight, IFL, RPS, NTD. Is IFL? RPS.
We're standing by now for Launch Director Bob Seek to finish pulling the last few members of the team. NASA Test Director Al Sofji has already completed his poll of the console operators here in Firing Room 1. And it does appear that we are go for a TAL site at Ben Guerir today. And it does appear that the rain showers have dissipated in the Kennedy Space Center area.
5 minutes to pick up and count. And MTD, PTC, go ahead. That's firm.
NTD flight 212.
Stand by, flight. Countdown clock will start in 4 minutes. Go ahead, flight.
Okay, we're going to be go on RTLS, and we're standing by right now to give the crew an update for Ben Greer weather.
Okay, I copy, launch director. Go ahead and give me the update, flight.
Okay.
Atlantis, Houston, with updates on your RTLS and TAL.
Ready to copy, Frank.
Roger, RTLS forecast remains the same for winds, altimeter, and weather, KSC 15. We're going to go with Ben Greer 36 for TAL. Forecast weather there is 9,000 broken, 20,000 broken, 6 miles in haze. Currently reporting 8 miles, no visibility problems. Forecast winds 350 at 10, gust to 15. Altimeter 3015.
Countdown clock will start in 3 minutes.
Okay, we copy, Frank. Thank you very much.
Roger, and that's nominal aim point and nominal speed break at both sites.
9 and hold at 5, waiting our call. Roger.
Last transmission on 212 other than flight. Repeat your transmission.
Ignore that.
As launch director, NTD, I'm going to go through my poll at this time, although we're still working the weather, so we'll have to hold at 5. Understand? Payload operations. Payload operations are go. Roger. Engineering director.
Launch director, I polled the technical community, and you'll have a consensus to proceed with this launch. Good luck and Godspeed.
Copy. Safety and quality director.
Safety and quality, go for launch.
Launch director, could you stand by, please? We'll pick up in 2 minutes. 2, 1, mark. 2 minutes to pick up with count.
NTD flight 212.
Go ahead. You ready to start recording?
We're ready to do that. Also, we have a go for launch, both RTLS and TAL, and we're go.
Understand. Copy that Cape Weather launch director.
Launch director, this is Cape Weather. We have no launch weather criteria violated. Wind for launch at the pad from 1.
Having his final go for launch, and flight in Houston has also polled their team members, and they are go for launch at this time. Weather at our TAL site, Ben Greer, is acceptable, and also here at Kennedy Space Center for an RTLS situation.
Why don't you plan on holding at T-5, and let's take another look at the TALs.
Understand. Launch director, copy? Good copy. So we'll pick up at 9 on the clock. Understand.
We will be picking up with the count at T-9. However, we do need to look more at the weather situation at the TAL site.
5, 4, 3, 2, 1, mark.
T-9 minutes and counting.
Has been initiated.
The ground launch sequencer has been initiated. We're counting down now to T-5 minutes, and we'll hold for clearance at the TAL site for weather.
NTD ISL 212. Go ahead. Recorder's activated. Copy, thank you. PLT, OTC, configured fuel cell, essential bus source switches.
PLT.
T-8 minutes and counting.
Essential buses are connected.
Orbiter AC electrical bus sensors have been placed on monitor by pilot McCulley. At T-minus 7 minutes 30 seconds, the orbiter access arm will be retracted away from the vehicle.
Let me get a go from flight before 5. GLS entity. GLS will go for OAA retract. Go ahead, NTD. Okay, configure to hold at 5. Countdown clock will hold at T-minus 5 for your request.
We start a retraction of the orbiter's access arm, and we are configuring to hold a countdown at the T-minus 5 minute mark, right before we start orbiter auxiliary power units.
Entity Flight 212.
Go ahead, flight.
Okay, we're going to be go on TAL, but we're going to have to switch sites to Zaragoza. So we hold at T-minus 5. We can give the crew an update.
Copy.
Flight controllers now looking at Zaragoza as our TAL site, and we'll be updating with, flight crew will be making these updates to the orbiter's computers at T-minus 5 and holding. T-minus 6 minutes, 30 seconds.
JRPS, OTC. JRPS. Start APU and hydraulic strip chart recorder. Running.
APU strip chart recorders are now started recording data.
Perform APU pre-start except for fuel tank ISO valve opening.
CLT, copy.
McCulley will configure switches in the cockpit to put the APUs in the ready-to-start configuration.
The APU pre-start is complete with the exception of the APU fuel tank valves.
Copy.
T-minus 5 minutes, 30 seconds. Clock will be holding at T-minus 5 minutes to update the orbiter's computers for a TAL site of Zaragoza.
Countdown clock holding at T-minus 5 minutes. Our countdown clock is holding at 5 minutes.
T-minus 5 minutes and holding.
Go ahead.
We're ready for your briefing.
Roger.
Atlantis, Houston.
Good, thanks.
Roger, one more change to the TAL site. We've developed some showers at Ben Guerir. We're going to change primary TAL to Zaragoza 30. That's area 5 on spec 50. Forecast weather at Zaragoza, and also change the TACAN to 81 X-ray. Forecast weather at Zaragoza, 3,000 scattered, 9,000 broken, and 7. And they say it's a thin layer at 9,000. Forecast wind 080 at 8. Gives you 6 tail, 6 right. Altimeter 3015. I'll copy.
Copy all that, 3015.
Flight launch director 212. Houston flight launch director.
Go ahead, Launch Director on 212.
Okay, with that, we have a go on TAL weather.
We have a go on TAL weather with Zaragoza, which we're configuring to at this time. RTLS is also go, so we're go for launch.
Copy, or you go then to pick up the clock at 5.
Stand by 1 second.
T-minus 5 minutes and holding, standing by now for the orbiter computers to be updated with the last minute information for a Zaragoza TAL site.
Okay, we just want to verify the crew has configured the TACANS to 81 X-ray, and then we're go. Can we go ahead and ask crew that? Confirm, verify it.
CDR and condition.
Okay, it's in work. Stand by just a minute. Okay, NTD, we have 81X set in the TACANS.
And NTD, this is flight 212, we're go.
Understand, launch director. Copy, I'm good to proceed, finish up the APU pre-start. PLT is OTC, you can open the APU fuel tank ISO valves at this time.
Will call.
Now getting ready to configure APUs for the start.
We're open, and I've got 3 gray talkbacks.
Copy that, thank you. And launch director, we're looking for a go to pick up the launch. Yes, go to proceed. Okay, understand. CDR and PLT, we're going to pick up in approximately 10 seconds.
Roger.
Countdown clock will be starting momentarily.
GLS, pick up on your mark. Clock will resume on my mark. 3, 2, 1, mark. T-minus 5 minutes.
T-minus 5 minutes and counting.
Orbiter APU start.
We have a go for orbiter APU start.
CLT.
And CDR, reconfigure heaters.
Heater reconfig.
Commander Williams has been asked to reconfigure the orbiter heaters for launch.
Looks like we got 3 good APUs.
McCulley reporting we got 3 good APUs, and Williams reporting the heater reconfiguration is complete. T-minus 4 minutes, 30 seconds.
OTC APD 1074 is complete. Copy.
T-minus 4 minutes.
Go for purge sequence 4.
Final purge sequence of the main engines will begin. Chamber coolant valves of the main engines will be opened to prepare for engine start. At the 1 minute point in the count, an engine ready indication will be given. At this time, the 3 main engines are being gimbaled and positioned for start.
OTC 1081 is complete. Copy.
T-minus 3 minutes and counting.
GLS is go for ETLO2 pressurization.
Pressurization of the external tank liquid oxygen tank for launch has started. The gaseous oxygen vent hood will be retracted from the orbiter in the next few seconds.
PLT, clear caution and warning memory. Verify no unexpected errors.
T-minus 2 minutes, 30 seconds. Orbiter test conductor has requested pilot McCulley to clear the caution and warning memory system. Liquid oxygen tank now reported at flight pressure.
Warning memory is cleared and no unexpected messages.
Copy, and flight crew, close and lock your visors. Initiate O2 flow and have a good flight.
T-minus 2 minutes. Flight crew's been instructed to close their visors.
We're ready, thanks.
GLS is go for ETLH2 pressurization.
We have a go for pressurization of the liquid hydrogen tank. Less than 2 minutes away now from launch. All systems are go.
1 minute.
1 minute, 30 seconds. 3 engines are ready, and the liquid hydrogen tank is at flight pressure.
One minute.
T-minus 1 minute and counting. The heaters on the booster joints are being deactivated. T-minus 45 seconds. T-minus 31 seconds.
Let's just go for auto sequence start.
We have a go for auto sequence start. Atlantis' 4 redundant computers have primary control of critical vehicle functions through liftoff.
20.
T-minus 20. T-minus 15. 11. 10. 9.
Let's go for main engine
We have a
start.
go for main engine start. 6, 5, 4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
Houston now controlling.
Tower clear. Well programmed.
Roger, roll, Atlantis.
Roll program initiated, about 110-degree roll maneuver. Guidance confirms a good roll maneuver. 3 engines throttling back now to 65% as Atlantis passes through the area of maximum dynamic pressure. Throttle's now at 65%. APU's looking good. Velocity 2,000 feet per second. Velocity now 1,400 feet per second. Downrange distance 3 nautical miles.
Atlantis, go at throttle up.
Engines now throttle back up. Engines now back to 104%. All systems performing well. Standing by for separation of these solid rocket boosters at 2 minutes and 4 seconds. Velocity now 2,700 feet per second, downrange 10 nautical miles. Separation of SRBs confirmed. Velocity now 4,200 feet per second, downrange 33 nautical miles.
Atlantis, performance nominal.
The performance nominal call. Performance nominal means that we are getting the expected thrust from the combination of the SRBs and the 3 main engines. Velocity now 4,800 feet per second, downrange 53 nautical miles.
Atlantis, APU 1 to high speed. That's a real shift.
That call no impact. Velocity now 5,000 feet per second.
Atlantis, 2 engine Zaragoza.
2 engines Zaragoza.
The 2 engine Zaragoza call means that Atlantis could reach the transatlantic abort site at Zaragoza if that became necessary on only 2 engines. Velocity now 5,700 feet per second, downrange 86 nautical miles. All systems aboard Atlantis performing well. Standing by for the negative return call. A correction for the press to ATO.
Atlantis, negative return.
Negative return.
Atlantis can now not return to the Kennedy shuttle landing facility. Downrange 136 nautical miles, velocity 7,400 feet per second. APU still performing well. Booster officer confirms 3 stable engines at 104%. Velocity is at 8,600 feet per second. Atlantis downrange 183 nautical miles.
Atlantis, press to ATO, select Ben Guerrier.
Press ATO, select the Bengal.
The press to ATO call means that Atlantis could lose performance of 1 engine and still make a safe orbit.
Group Ben Guerrier 109.
Group 109.
Velocity now 11,000 feet per second, 278.
Press to MECO.
Press to MECO, Houston.
Downrange 293 nautical miles. The press to MECO call assures that Atlantis can reach safe and nominal engine cutoff if 1 engine should fail. Velocity 13,000 feet per second. Atlantis 338 miles downrange from Kennedy.
Atlantis, single engine Zaragoza 104.
Single engine Zaragoza.
That call means that Atlantis could reach the transatlantic abort site at Zaragoza on only 1 engine. Velocity is now 15,000 feet per second. Atlantis 398 miles downrange.
Atlantis, single engine press 104.
Single engine press.
Velocity is now 16,500 feet per second, downrange 450 nautical miles. Atlantis could now reach safe orbit on only 1 engine at 104%. All systems performing well, 3 engines at 104%. APU's looking good. Velocity now 20,000 feet per second, downrange 572 nautical miles. Coming up on main engine cutoff at 8 minutes and 32 seconds. Main engine cutoff confirmed by our booster officer.
So about 25.9 plus 310 on the H-time.
Roger that, Don. You look marvelous going up. ohms 1 required. You are go for the DTO.
Ohms 1 required and light echo, Frank.
Atlantis, we see the message on the payload. We think it may be a transient. We'll get right back to you.
Okay, and you got a real bad echo, Frank. We can understand you, though.
Roger. How do you copy now?
That's a lot better, thank you.
Flight Dynamics Officer confirm nominal performance on the ascent phase of the mission. No ohms 1 burn is required. Crew's been given the go-ahead to do a photography detail test objective. Mission Specialist Ellen Baker will move up from the mid-deck and be stabilized in the flight deck area to take some still photographs of the external tank as it falls away from Atlantis.
Atlantis, you've got to go for APU shutdown on time.
Go for APU shutdown on time, thank you.
Payloads officer has confirmed the message received earlier on the payload was a transient. There is no impact, and the payload systems all look good and in proper order.
Atlantis, Houston, we're with you through Tidris East now, and we've confirmed that the payload message is a transient, no action.
Okay, Frank, the echo is gone, and we had an SM0 thermal event message.
Roger, we're evaluating that one, Don.
Frank, it's an incredible ride.
You looked great. Congratulations to all of you. Atlantis, Houston.
Go ahead, Houston.
To start work on that thermal evap message, Don, we'd like on panel L1 to take the high-load duct heater to A/B.
Can work.
This is Mission Control. All aboard Atlantis going well. The crew was given one switch throw instruction to work a data indication here, received here on the ground about a thermal evap message. The environmental systems officer looking at that.
Atlantis, Houston.
Go ahead, Houston.
Don, you've got to go for a nominal ohms 2 on time.
Nominal ohms 2 on time. That's good news. Thanks.
Roger that.
That call to the crew, very good news. They are go for their nominal burn, orbital maneuvering system 2. That burn is set for a mission elapsed time of 39 minutes 48 seconds. Both ohms engines will be used. The duration of the burn will be 2 minutes 22 seconds for a delta velocity of 219 feet per second. Mechanical Systems Officer reports that the crew is in the procedure shutting down the 3 auxiliary power units. A transducer message on auxiliary power unit number 1 was gotten just a few minutes after launch. However, that was determined to be a transducer, and that auxiliary power unit performed well throughout the launch phase.
Atlantis, Houston for Mike.
Stand by just a second. Go ahead, Frank.
Roger, stand by. We'd like to take the FES Pry A to off and secondary on. We see the FES is shut down.
Okay, Frank. A is off and secondary is on.
Roger that. And we saw a good shutdown on the APUs. You can disregard the thermal APU message. And APU looks one looks good. We're going to evaluate it a little further.
Okay, I was just going to ask you one question on the shutdown. Whether you want me to leave the speed select in high or go back to normal, or whether it made any difference.
You can leave it in high for now, Mike.
Okay.
Atlantis, Houston, on your evap problem.
Go ahead, Frank.
Roger, it looks like we might have had some ice in the duct. We're going to run the secondary for a while and evaluate it, but it's looking pretty good at the moment.
Okay, that's good news. Thank you, sir.
And Atlantis, you can disregard the MPS helium messages. That's the baggy purge.
Roger that.
The Environmental Systems Officer confirms with the flight director that the thermal evaporator message received earlier by the crew was probably due to icing in the high-load duct in the flash evaporator system, or in the perhaps something in the topping system of that flash evaporator. This is a similar signature that we saw on mission STS-26. Crew was directed to switch over to the secondary system. They have done that. That will likely blow out any ice in that duct, and the flash evaporator system is performing well on the secondary. Flight controllers do not see any mission impact at this time. This is Mission Control. The Guidance Navigation and Control Officer confirms that Atlantis is maneuvering to the ohms burn attitude, and the Propulsion Officer reports that all his systems look good during that maneuver. This is Mission Control. The flight director has polled guidance, navigation, and control, propulsion, and the guidance officer, confirming that Atlantis has maneuvered to the proper position for the OMS 2 burn. The prop officer reports that the system is configured properly for the OMS 2 burn, and guidance reports that the onboard targets look good for that burn as well. Burn will be a 2-minute, 22-second duration using both OMS engines. The delta velocity of the burn is 219 feet per second and is scheduled for 39 minutes, 48 seconds mission elapsed time. The time of ignition is just about 7 minutes from now.
Atlantis, Houston, we're going to be handing down to iOS in about a minute, and we'll stay with them until the burn is complete.
Okay, Frank, we copy.
And if we drop S-band, we'll still have UHF, and TDRS West AOS is about 0+49er, and expect some intermittent comm at that time due to TDRS being off the tail. And Atlantis, Houston, further words on your evap out? Atlantis, select left dome secondary. We see FA1 down at the MDM. Atlantis, Houston, with you, UHF through iOS. We saw FA1 down at the MDM. We need secondary TVC on the left domes.
That's complete, Frank, and we're working the yellow pages.
Roger that.
This is Mission Control. The FA1 down at the MDM means the flight.
We got stay one back with the power cycle, and should we stay on secondary gimbals?
That's affirmative. Stay on secondary gimbals and good job on the recovery. We're still working on picking up data through iOS. We're with you, UHF.
Roger.
That flight aft was recovered by a power cycle. The crew is still go for the orbital maneuvering system 2 burn. They will be using the secondary thrust vector. This is Mission Control. The crew is go for the burn. Coming up, time of ignition in 1 minute for that OMS 2 burn. The propulsion officer confirms that the configuration is good and all is ready. This is Mission Control. The propulsion officer confirms both OMS engines are burning and the burn looks good in progress. The duration of the OMS 2 burn is 2 minutes 22 seconds. Delta velocity of 219 feet per second. The burn will circularize Atlantis' orbit to 169 nautical miles altitude.
Atlantis, Houston, UHF only. 1 minute till LOS Indy, and we'll see you at 0+49 on the west, though we may have intermittent comm due to the attitude.
Okay, flight double echo, but we'll see you on Teeters.
Roger that.
This is Mission Control. We're out of range of the Indian Ocean Ground Station now, and our next voice contact with the crew will be through Teeters West on the, but it may be rather intermittent communication because of the antenna that will be used. Well, we will contact them again in about 6 minutes. At about 37 minutes mission elapsed time, the Data Processing Systems Officer reported that FA1, which stands for Flight Aft 1, and a Flight Aft and a Flight Forward are multiplexer, demultiplexers between the general purpose computers and equipment aboard the shuttle. The Flight Forward or Flight Aft, in this case it was Flight Aft 1, is a black box which sends signals from the general purpose computer to some piece of equipment or valve or so on. Due to the loss of the Flight Aft 1, the crew was instructed to switch over to a secondary thrust vector controller on the left OMS engine and was given the go for the OMS 2 burn. That burn looked good, according to data received on the ground before we lost signal from the crew. Data Processing Systems Officer is looking at the situation. About a minute and a half later, FA1 went down again, although the crew had recovered the use of that circuit through a power cycle. And we expect the Data Processing Systems Officer to recommend a port mode switch configuration after we go over to the Ops 2 computer phase for orbital operations.
Atlantis, Houston, with you through Tidris West.
You're loud and clear, Frank. We're into box number 1 of the post-insertion book and recovered FA1 again with the power cycle.
Roger, we copy that. That's good. And I've got a couple of notes for you when you're ready to copy.
Okay, go ahead.
Roger, we'd like to do some troubleshooting on the heater ducts, or on the high-load duct, about 5 minutes prior to rad activation in the post-insertion. Procedures we'd like you to use would be on panel L1, topping evap heater duct to AB, high-load evap. Then take flash evap controller secondary off. Wait 30 seconds again. Then take flash evap secondary on, ON, and wait 9 or 0 seconds. That should flush any more ice we've got in there. And then if the evap out temperature is greater than 70 degrees, 70, at that time, enable the high-load evap.
Okay, let me see if I got this straight. About 5 minutes prior to rad activation, top evap heater duct to A/B, then high load off, wait 30 seconds, secondary off, wait 30 seconds, secondary on, wait 90 seconds, and then if the evap out T is greater than 70, enable the high load.
That's a good read, Don, and we expect the evap out temp to be less than 70 degrees at that time, if the topper is working right.
Okay.
And Atlantis, Houston, also give us a call prior to doing this procedure so we can watch.
Roger.
Atlantis, Houston.
Go ahead, Frank.
We see FA1 again. No further action on that for now. Go ahead with the dips work, and we are working on a plan from down here.
Okay, we did a power cycle, all right. We got it back again here temporarily.
Roger that.
It's going again, we'll just leave it alone.
Roger that. We're working on a plan.
Okay.
Atlantis, Houston, with some words on your RTG cooling loop.
Go ahead.
Due to thermal expansion in the fluid there, you can expect an alarm at the OPS2 transition. It's on the aft accumulator only right now.
Okay, but the loop's okay?
That's affirmative.
Roger.
Your accumulator quantities are maxed out to 100%, but it's no problem for now.
This is Mission Control. The crew is working through the post-insertion summary timeline now, making the configurations necessary for orbital operations for Atlantis. The next thing coming up is the reconfiguration of the data processing system. The flight aft 1 was recovered at about, the crew reported at about 51 minutes mission elapsed time. They did another power cycle and brought it back, but about 53 minutes and 56 seconds mission elapsed time. The data processing systems officer reported that FA1 went down again. We've asked the crew no further action on that flight aft system right now until we get through the data processing systems reconfiguration. The DPS officer believes that a port mode after we get to Ops 2 will be adequate to take care of this. Also, the crew was given steps for switch on and off for the flash evaporator system as a troubleshooting method to see if it can flush any remaining ice out of the system. They will do a couple of switch throws, waiting 30 seconds in between. After 90 seconds of operation, if it is operating at greater than 70 degrees, they will simply go back to the secondary high load system. They were also alerted to expect a payload alarm because the volume in the forward accumulator has reached the maximum quantity because of thermal expansion related to the flash evaporator system. However, this is no problem. It does not impact the payload in any negative way, and the loops are all still all right, and everything is nominal and proceeding in good order toward a deploy at the expected time. The next important call that we will expect to get at about an hour and 30 minutes mission elapsed time will be the go for orbit ops.
Atlantis, Houston, you can disregard the left RCS message. That's due to FA1 being down. And also the DAP reconfig message. Atlantis, Houston.
Stand by just a second. Okay, Houston, Atlantis, go ahead.
Roger, a couple of things. We'd like you to go to the orbit pocket checklist, page 3-9, and work the procedure for the FAIO error. And also, you had a couple of messages on the APU system there. The Spec 87 thermal control, we think, was a transducer. You can, no action on that. And the Spec 86 APU hydraulic water boiler, water boiler 1 is controlling or is sitting right at the lower limit, so you may get a couple of alarms, but we think it'll warm up pretty soon.
Okay, copy.
This is Mission Control. Atlantis' crew has completed the reconfiguration of the data processing systems for orbital operations, and the crew was sent to the orbit pocket checklist for a procedure that should recover the flight aft 1 multiplexer demultiplexer that has gone down a couple of times, starting at about 37 minutes into the flight. And we'll be expecting to hear from them, and the DPS officer will also be watching his data here in mission control. Crew received a couple of alarms, one on an APU, and that was a transducer problem. No action is required.
And Houston, do you want me to do the procedure you read up on the RAD business before we start RAD activation?
That's affirmative. We're watching whenever you're ready to start.
Okay, that's gonna work.
Roger.
And the crew reports that they are beginning the procedure put together by the environmental systems officer to try to flush any ice out of the high-load evaporator system. The guidance officer reports that Atlantis is maneuvering to the payload bay door opening attitude.
Houston, Atlantis, dips.
Go ahead, Atlantis, and expect some intermittent comm here.
Okay, we worked 3-9 for the FA and got it back with a port mode.
Copy that. Good job, Mike. No further action at this time, and we'll watch it.
I thought this stuff only happened in the SMS.
Sim Soup was supposed to stay home today.
Frank, as you can see, the evap out T is less than 70, so can I go ahead with the RAD activation?
We'd like to wait just a couple of minutes and look at it. We'll get right back to you, Don.
Okay, thanks.
This is Mission Control. The crew recovered Flight Aft 1 multiplexer demultiplexer using the procedure in the orbit pocket checklist. The crew's reference to this happens only in the SMS is because this particular failure of Flight Aft and also Flight Forward MDMs is frequently put into simulations. So the crew has worked with this kind of failure before, many times in simulations. The environmental systems officer is watching the procedure in progress that the crew has been doing, switching.
Atlantis, the thermal water message is a transient, no action.
Okay, concur, thanks.
The crew was going through the procedure prescribed by the environmental systems officer to try to flush the ice out of the high-load evaporator duct and we're still watching the data here on the ground and expecting conclusion within the next few minutes from the environmental systems officer.
That's affirmative. Standby 1 done. Atlantis, Houston, we'd like to go ahead and enable the high load now, and you've got to go for rad activation.
Okay, high load to enable, and we'll do the rad activation. Thanks.
And we're still evaluating what we see in the topper.
Okay.
Atlantis, Houston. Atlantis, Houston.
Houston, Atlantis, go ahead.
Roger, you've got a go for opening the payload bay doors and a preliminary go for orbit ops, and you can get out of your suits.
Okay, understand. Go for payload bay doors and preliminary go for payload ops.
That's affirmative.
This is Mission Control. The Environmental Systems Officer reports that good flow has been established in both loops of the radiator system. The flash evaporator system is back operating on the secondary system, the high load system, and further evaluation is going on about the flash evaporator system. Crew's been given the go-ahead for payload bay door opening and a preliminary go for payload operations. That's contingent on the full opening of the payload bay doors. The doors are considered fully open at 175 degrees. Crew was also told that they could get out of their launch entry partial pressure suits, and they welcome that go-ahead since the suits are a little bulky and it's much easier to maneuver around the cabin wearing just the coveralls.